All right, so last section we learned about the hindbrain, and you didn't have much of a review, so let's just take a look at what we learned last time. So we learned about something called the hindbrain. The hindbrain stops here. So we've got the medulla, which is for your vital reflexes, your heart rate, and your breathing, your vomiting, and your sneezing. And then we learned about the pons. It's where fibers cross from left to right. It's called bridge. It also has many nuclei inside of it for sleep. And then the cerebellum is this cauliflower looking part of the brain that has a major role in learning, and it also has a role in balance and coordination. Then we learned that there's the reticular formation, or the ascending reticular activating system. It's a network of fibers that runs through here that's responsible for attention and arousal. So it's mediated by the cortex up here. Whatever you think about all the time, it alerts the section of fibers right in this area of, oh, make sure that you pay attention to this because this is what's important to them. And then it kind of screens out all the other things that aren't so important. So what we're learning about in this section, which is entitled the midbrain, is we're learning about this small area right here, very small area. Your textbook delegates just one little paragraph to it in this particular area. So what we have is your textbook mentions these three structures. It doesn't go into them at all. It talks about the tectum is the roof of the midbrain, and the tegmentum is the floor of the midbrain. And then it talks about the substantia nigra, which is a nuclei that's black. It's involved in movement. The ventral tegmental gray is an area in here, tegmentum, ventral tegmental gray, and that's a major area where we see dopamine receptors. It's kind of what they believe might be the start of the addiction area, that it feeds its information into this area called the nucleus accumbens, which is this area right in here. And this area right in here, the nucleus accumbens, they think may be the major area for addiction. So the ventral tegmental gray feeds right into that. It has a role of directing behavior. It's also involved in pain, many different things. But for our purposes, for what's on the test, is I would like you to know, to be able to recognize, if you saw these words, tegmentum, tectum, substantia nigra, I'd like you to understand where they are in the brain. They're in the midbrain. So what we're going to do with these structures right here in the box is we're going to go into a little bit more depth and hopefully teach you some interesting information about them. So let's go on to our next slide. So here's another picture. Now the brain has been flipped, and we're looking at the midbrain again to kind of get you into the mode of what are we talking about. This is the medulla, this would be the pons, this would be the cerebellum, and then the reticular formation would be running through here. This would be the top, the tectum. This would be the bottom, the tegmentum. Then we're going to look at these structures right here. We're going to find out this is the pineal gland, the superior colliculi, and the inferior colliculi. Okay, so hopefully I startled you a little bit. Sorry if I startled you too much, but the way that I do it in my classes, I make a really loud noise. You know, they're kind of all drifting off, and then I make a really loud noise, and you'll see their heads just pop right up and look at the screen, or look at me. You guys will be looking at the screen. So when I do a sudden movement or a sudden loud noise like what I just did for you, you've got these two structures, the superior colliculi and the inferior colliculi, to orient you. So the superior colliculi is your visual orienting reflex. So when you see something out of the corner of your eye and you turn your head very quickly, that would be the superior colliculi. The inferior colliculi is for, that's when I yell something, you turn your head and look immediately at me. So when we talk about orienting reflexes, it's this way that your brain is set up that when it sees something or hears something that's not supposed to be there, then it orients you for that. So it's definitely a survival mechanism. And in fact, like I can even kind of relate it, like on the freeway, a lot of you are, there'll be an accident, and a part of you says, don't look, don't look, don't look, but you kind of want to look because if you remember, the reticular formation is running right through here, right next to these, and someone dying is very important to us, and so we tend to want to see what's going on. They're right in the same area as something different, something new, what's going on here. Now, when we do a sheep brain dissection in class, we won't do it here, but when we do a sheep brain dissection in class, we can see these structures very well. So this line would be the superior colliculi, and this line would be the inferior colliculi on a sheep brain. So they're very big on a sheep brain, but look at how small they are. But you can still see them very well here. Look at how small they are on the human brain in comparison to how large, what a big area they take up in the sheep brain. Anybody know why? Well, the reason would be because sheep are more prey and we're more predators. So they have to rely very heavily on anything out of the ordinary. They have to orient and make a response immediately. So let's go on to the next one. The pineal gland. Now this is a cool part. So it's right in the dead center of the brain, and we'll see what all these pictures mean in a minute, but check this out. Look at that. It's like a perfect circle. And you know what? This is, I believe, a human brain, but even on the sheep brain, when we do this sheep brain dissection, I mean, it is perfect. It's like this mold that you can take out and stick on the table. So it's right in the dead center of the brain. So look at this statement up here. Descartes thought that the seat of the soul was in the pineal gland. That's why I said, oh, this is a good one. So it's this perfect circular structure, and you can see why someone might think, oh, that's very important because it's very in the center of the brain. So Descartes lived outside of the Palace of Versailles, and there were these pleasure gardens. And in his day, these pleasure gardens, this was actually at the Saint Germain, I believe, en Laye. It's not at the Palace of Versailles, but it's in the suburbs of the Palace of Versailles. So he had access to this, and it was like one of his favorite places to go. Because remember, they don't have Nintendo, they don't have the smartphones, computers, television, nothing. So the gardens were a big deal, and these are absolutely beautiful. So when he was a kid, it was probably like Disneyland. Oh, Mom, take me to the gardens, take me to the gardens. So at these particular gardens, they were made by two brothers that were really into hydraulic statues. So they would have these water powered statues, and even I saw a rumor like in one article that said that some statues could even talk. But basically the way they had these gardens set up was there would be a flat rock, and as you stepped on the flat rock, there would be a bag of water under the flat rock. So you step on the flat rock, and then that would push the water up into the statue, and it would make the statue move or dance. So look, this was back in the late 1600s or early 1600s area. Can you imagine if I put this up on Universal City Walk? I think people would still like it. You know, if there was a flat rock that you could step on and you could make a statue move, you would see people up there stomp, 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 right? So can you imagine how incredible this was to walk through these glorious gardens during his time, and you could actually make the statues move? So what's interesting about this is Descartes, as he got older, he actually joined the military. I don't know if you guys know that. We don't know exactly why he joined the military. He did have some other family members that were in the military, so perhaps he was following their footsteps. But this is what was said about him, is after a battle, he would go onto the battlefield and look at all the corpses and cadavers laying there, all the dead bodies, and he would kind of examine them. Because in his time period, you couldn't examine a dead body. That was against God, and he would just go and he would look at them. And so it's believed that he saw this perfect circle in the middle of the brain. So Descartes, who had gone to this garden all the time, thought that maybe people are just like the statues in the garden. There's hoses that run through them, And then there's fluid in the hoses that make the person move. And you know what? Truthfully, he wasn't that far off because it is fluids that make us move. But if that is the truth, then where's the soul? So he was wrestling with a question that we're still wrestling with today is, do we have a soul? So, interesting sidelight. I don't know if you've ever heard that statement that said people lose weight when they die and that proves that there's a soul. Well, actually, that was a study that was done in the early 1900s, and they actually had 6 scale beds that would measure people's weight as they died, which is pretty gruesome, amazing just to think about that. But just so you know what the results were is 2 of them did lose weight, but then 2 of them gained weight, and 2 there was problems with the register, or they didn't show any differences at all. So that we lose weight when we die, as far as the soul leaving, it tends to be very, very erratic. So anyway, he thought that the soul was housed right here in this pineal gland. Now, let's talk about what the pineal gland actually does, and then we'll get on to some more really fascinating information. So what the pineal gland does is it controls sleep and wake cycles. It controls our circadian rhythm. That's the 24-hour pattern that we have, that you tend to get hungry every day at about the same time. You probably wake up every day at about the same time. You probably go to sleep every day at about the same time. Now, those of you that are young, you might be more erratic because you're not quite set up. But then you hear people that are like over 30 and they say, oh, I don't want to go out and party the way I used to because it just makes me so tired. I can't handle it the same way. So the older you get, the more you get kind of set in your way, the more your circadian rhythm is getting kicked in. So your circadian rhythm is your 24-hour cycle that you have a body pattern. And this pineal gland helps to regulate it. Now, here's another interesting sidelight. Not only do we have a circadian rhythm, but there's some evidence that we have a circannual rhythm. And the reason why this is so fascinating, and the reason why I really want you to think about this, is you might see patterns in your life. For example, let's pretend that someone who you were close to but not super, super close to died last year in May. And you were sad that they died and so on and so forth, but kind of life went on and you kind of got all busy. And then this May, you start to feel sad and you can't quite figure out why. And so you start to blame the people around you. Really, it's that your body might have been sad. It could have been because you're circannual, because you were sad the year before. A lot of you will find that you get sick every year at about the same time. Others of you will find that you gain weight and lose weight at certain times every year. Sometimes you'll even think of the same people at certain times of each year. So not only is there a circadian rhythm, but there's a circannual rhythm. So what this pineal gland does is it releases melatonin. So melatonin is a hormone that helps to regulate sleep and wake cycles. So have you ever noticed that on a cloudy day, you don't really want to leave the house? Even that the temperature is the same as a sunny day, there's something about a cloudy day that you just want to stay in the house. You just kind of want to stay in bed. So what happens is when the sun comes up, it goes into your eyes. See, that's what this picture is. When the sun comes up, it goes into your eyes and it goes straight back to this pineal gland and it says, stop releasing melatonin. So when this stops releasing melatonin, that kind of raises your body temperature and you feel like, oh, okay, I want to go do something. I'm ready to go, so on and so forth. What jet lag is it's you need to reset this whole pineal gland thing. Is you go across time zones and you're on that circadian rhythm, and then your body is trying to go with that 24-hour cycle, but you've crossed time zones and now you expect it to just adjust. So it doesn't just adjust with the light. It slowly adjusts with the light according to the light cycles, but it doesn't adjust very quickly. So some people actually take melatonin when they're trying to get to sleep because melatonin will lower your body temperature. Also, people take melatonin sometimes as an anti-aging because as we age, we don't sleep as well, and so it helps to promote better sleep, so on and so forth. All right, so that's what the pineal gland does. Now, one other interesting sidelight before we leave this part of the brain is I'm not sure if you've ever heard of DMT. It's a drug, it's a hallucinogen, and it's known as the spirit molecule. So, people who take DMT, they report that they talk to God and that they have hallucinations that are very spiritual in nature. But anyway, where DMT seems to work is it has got a structure that's similar to serotonin and melatonin. I mean, if I showed you the structure, you'd be amazed at how close it is to serotonin and melatonin. By the way, melatonin and serotonin are very similar. We'll talk about those next chapter, but I'll bring up a couple things here. And so the DMT actually seems to work in this area of the pineal gland. Also, when people talk about near-death experiences where they saw the light, they went to see God, so on and so forth. Again, they are relating to this to activity in the pineal gland. So those are all like kind of interesting trivia that go along with the pineal gland. Descartes believed it was the seat of the soul, and the reason, though, that I believe that Descartes thought that it was the seat of the soul, because it is this perfect circle and it's right in the center of the brain. But then, even now, the drug that is known to get us in contact with God, or people have very religious experiences, it works on the pineal gland. And also death, near-death experiences are believed to involve this pineal gland. So those are all interesting sidelights. Let's review what we learned in this segment, and then we can stop for the midbrain. Okay, we're going to go back to this side. Oh, that's the hindbrain, sorry. Okay, let's go to midbrain. Okay, so we learned about the midbrain. We learned some pretty interesting things. We learned that the tegmentum, the tectum, and the substantia nigra are all found in the midbrain, and there's other areas that are in the midbrain that are very interesting. But the ones that we're going to focus on in this class about learning are the superior colliculi, the inferior colliculi, and the pineal gland. So the superior colliculi is visual orienting reflexes. So you could kind of remember that your vision is usually superior to your audition, to your hearing. So superior is vision, and inferior is your auditory or your hearing reflex. When you hear a strange sound or something comes out, you automatically orient and look to try to see what that is. And then with the pineal gland, we learned that it's a gland that's in the center of the brain, and it releases melatonin, and it tends to control our circadian rhythm. It helps our 24-hour cycle, and it releases melatonin, which can lower our body temperature and will act in response to the light. I don't know if you've ever heard of seasonal affective disorder, but seasonal affective disorder is some people get very, very depressed in the winter months because there isn't as much light and when it's cloudy all the time. So about 20% of the population seems to be affected by lack of sunlight, and some people extremely so, and so they actually go into a depression in the winter because of this problem with melatonin. The melatonin continues to stay high, and that seems to depress us. When the sunlight comes in, it stops the release of the melatonin. So the way that they actually treat seasonal affective disorder, which we'll be learning about in chapter 15, is with light therapy. Is you wear a visor and it simulates the sunlight, and that stops the melatonin, and that raises your levels of so you're not depressed. Okay, so we'll go on to the forebrain in the next segment.